Exam 5. Let's jump into it. All right, so our first question is asking us to find the mean absolute deviation of this data set. So anytime you're asked to find the mean absolute deviation, you want to first find your mean. Mean is another way of saying average. Then you need to do your subtraction. Okay, and your subtraction is taking all of your numbers from your data and subtracting it from your average. And then you need to take your mean or your average again of all those new numbers that you get. Okay, so anytime you see mean absolute deviation, you need to do your average, subtraction, and average again. And the fastest way to do that would be with a calculator. So go ahead and grab one. This is the Desmos calculator that I always use. And let's find our average. So let's type all these in. And when you guys are typing this in, especially since this is going to be on your exam, always double check to make sure that your numbers are going to be correct, because it's very easy to make a simple mistake when you're typing stuff in. So I got 156, and we need to divide that by the total number of numbers we added together, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which means that my average is 15.6. So I did step 1. Step 2 is going to be doing my subtraction. So I'm going to take that 15.6 and subtract it from all the numbers in my data set. Notice how I am subtracting the bigger number first. That is because I want my answers to be positive. So when you're doing subtraction, make sure you're doing the bigger number first so that you will always get a positive number. Now before I do this, I'm going to double check and make sure I subtracted 10 numbers. So I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So now all we need to do is take all of these new numbers that we have here, our distances, add them together, and then divide them. So that's 9.6 and 3.6. And then after that was 6.4. Then we have 4.4. 1.6, 7.6, 0.4, 6.4, 1.4, 3.4. So double checking 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I miss one? Oh, nope, there it is. It's at the end. 10. So I'm going to take that 44.8 and divide it by 10, which gives me 4.48. So my mean absolute deviation for this problem is going to be 4.48. So for mean absolute deviation, average, subtraction, average. So our next question here, we want to know what is the mean height for both of the teams and what is the difference. So I want to know what the mean height is. Remember, mean is another way for saying average. So anytime you read the word mean, you need to add up all your numbers and divide them. So we need to figure out the football team and the basketball team. And so let's just pull open that calculator again and start adding and dividing. So let's do football first. So 72 plus 82, 68, 79, 73, 70, 74. So 518. We're going to divide that by 7 because there are 7 numbers. Let's do basketball. So we have 78, 79, 82, 75, 78, 77, 81. So I got 550, and we're going to divide that by 7 again. So for the football team, we got 74, and for the basketball team, we got 78.6. Now we also want to know what is the difference, which means we need to subtract these. So 78.6 minus 74, which would give me 4.6. So these over here are the averages or the mean heights, and 4.6 would be the difference between their averages. Now this next question is asking us, well, what is the mean absolute deviation for each and which team has more variability? So we already know that the average of the football team is 74, and we know that the average of the basketball team is 78.6. So that's our first step. We already did that in the previous problem. So now all that we need to do is type in and do all of our subtraction. Remember, first is find your average, second is do subtraction. So let's do subtraction with the football team first. And I'm subtracting all my data points from my average or my mean. Double check here. 1, 2, 3, 4, 5, 6, 7. Oops, here I flipped the numbers. That should be the third one, which is 68. There we go. Alright, so let's add up all these. So 2 plus 8 plus 6. And then I have 5 plus 1 plus 4 plus 0. I'm going to include the 0 in there because the 0 is a part of our data, and so that will affect our answer if we don't put that in there, and you'll see what I mean by this next step. So now we have to do our division. So we need to do 26 divided by the total number of numbers we added together, which would be 1, 2, 3, 4, 5, 6, 7. That 0 counts as a number. And that would give us 3.7. So now let's do the same thing with the basketball team. Then we have 82. So a lot of this mean absolute deviation, actually all of it, you should be typing it into a calculator. If you're not using a calculator, please grab one. It will make your life so much easier. It is not cheating if you use a calculator, I promise, because I am using one, and you're using your time more wisely by typing this into a calculator. Because you can do it by hand if you really have the desire to, but I mean normally these exams are pretty long for you guys, so I want to try and save you as much time as I can. So this would be 1, 2, 3, 4, 5, 6, 7, perfect. So 0 0.6, 0 0.4, 3.4, 3.6, 0 0.6, 1.6, 2.4. Alright, so 12.6 divided by 7. Okay, so on the first team we got 3.7 and 1.8. So 3.7 and 1.8. So these are our mean absolute deviations. Then the question says which team has more variability? Well, variability is related to your MAD. So whichever team has a higher MAD is going to have more variability. So the football team has more variability. Alright, so we have this store and it has these different visitors. We want to know which statement best compares the variability for traffic of the two stores. Okay, so variability again has to do with your mean absolute deviation. We don't care about the mean, it's just mean absolute deviation. So it looks like the mean absolute deviation for both of these stores is probably going to be the same, just because their MADs are almost the same number. One's not significantly bigger than the other, so I would say that both stores were going to have the same variability. So same question, but same data, different question. We want to know which statements best describe the difference of the means in terms of the mean absolute deviation. So to do this, we need to do some subtraction. So we need to do 2400 minus 1895. And then we're going to divide this by 100 because our mean absolute deviations are close to 100, and 100 is a nice, easy number to do division with. So let's type it into a calculator. So I have 2400 minus 1895, which gives me 505. And when we divide that by 100, we get about 5. about 5, right? 5.05 is very close to 5, which means that the mean absolute deviations are about 5, or sorry, the means are about 5 mean absolute deviations apart. All right, moving on to dot plots. So we want to know what is the mean of this data. So again, mean is average, and if I were to take a calculator, now notice how 7 has 2 dots above it. That means I should have 7 plus 7. 8 has 3 dots above it, which means I should have 8 plus 8 plus 8. So 5 plus 6 plus 7 plus 7 plus 8 plus 8 plus 8 plus 9 plus 10 plus 10 plus 10. There's 4 12s and 2 13s. I get 162, and let's divide that by the total number of dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And I get about 9.5. Oh, whoops. Did I skip one? Oh, I went to the next one, that's why. So mean is going to be 9.5. So mean is 9.5. Alright, so the next question is asking us what is the range of this data, and to figure out the range of your data, all you need to do is take your biggest number and subtract it from your smallest number. So 13 minus 5 is going to give me 8, which means that my range is 8. Then finally, we want to know what's the mean absolute deviation. Again, remember, you need to first find your average, do your subtraction, then average again. We already know that the average of this data, or the mean, is 9.5. So next step would just be to do all that subtraction in our calculator and then divide it all up. So let's get rolling. I typed it backwards. So remember that if you have, like for 8, I have 3 dots above 8. So that means that I need to do my subtraction with 8 3 times. I'm going to copy paste this 4 times. 1, 2, there we go. 13 minus 9.5 2 times. Perfect. Alright. So let's add up all these together. So 4.5, 3.5. We're going to have 2 2.5s, 3 1.5s. Just to double check. Whoops, I accidentally moved this. So 3, 2, so 4 0.5s. And then we have 1, 2, 3. Oh, that's why. I skipped 11 on my number line. Interesting. Oh well, we'll roll with it. Pretend there's an 11 there and there's no dot. Counting is hard sometimes, you know. Let's do 2.5 4 times. So 1, 2, 3, 4, and then we have 3.5 twice. I forgot my 0.5. This is why I say always double check. So we get 36.5, and we're going to divide that by 17, which is the total number of numbers, and we will get 2.14. Which means that mean absolute deviation is going to be 2.14. Alrighty. So here we have company A and company B, and it tells us customer service ratings on a scale of 1 to 10 for these two different companies. We want to know which company is likely to have a larger mean customer service rating and why. So remember, mean is your average, and if you are adding together bigger numbers, you're going to get a bigger mean. So company B, look at all of these data points between 6 and 10 versus company A has all their data points between 1 and 5. So company B is going to have a greater mean because all of their scores are bigger than company A. So here we have a table and we have class R, S, T, and U. So we want to Now, which class has the most variability? So variability means you're looking at your MAD. Don't care about this. I want to know which class has the most. I'm looking for the biggest number. 13 is the biggest number, which means class T has the most variability. A manager of an amusement park is studying wait time of popular roller coasters, and he's collected this data for Friday and Saturday. We want to know what is the difference between the mean wait times. Round your answer to the nearest tenth. So to find the difference between the means, well, first we have to figure out what those means are, which means we need to take the average. So let's start with Friday. I'm going to add up together all the wait times for Friday. And then just double checking that you're typing in all the numbers correctly. So 199, we're going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Then let's look at Saturday. So it's like a finger workout, typing in all these numbers. Alright, so 221, how many numbers are we adding together? So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 again. So we have 11.05 and 9.95. Notice how we want to find the difference, which means we need to subtract these two numbers. And when I subtract them, I get 1.1. So that means there's a difference of 1.1 minutes in wait time between Friday and Saturday. Alright, so we want to know the mean absolute deviation for each, it tells us that the mean absolute deviation for each data set is about 1. Which statement best describes the difference in the mean number of siblings for both classes? Okay, well, we know the mean absolute deviation is 1, which is great, but in order to figure out how far apart these actually are, we need to actually find the average of both of these. So, bring back that calculator. 1 plus 1 plus 2. So 21 divided by, let's see, that is 1, 2, 3, 4, 5, 6, 7, 8. So that's A. Let's do B now. 1 plus 2 plus 2 plus 3 plus 3 plus 3 plus 4 plus 6. So 24 divided by 5, 6, 7, 8 again. So I have 3 and 2.6. So let's do that subtraction. So 3 minus 2.6 gives me 0.4. And if I take the difference and divide it by my MAD, which is what we're supposed to do when we're trying to figure out how far apart they are, I get 0.4. So 0.4 isn't one of these numbers, but it is very close to about half. So the mean number of siblings would be separated by about a half of a mean absolute deviation. Alright, so here we have a random sample of male students in high school and middle school, and we want to know which 3 statements best apply to this data set, or best compare them. Okay, well, the mean absolute deviations are the same, right, which means that the data, or the spread of both of these, are also going to be the same. So the spread of middle school boys to high school boys will be the same because our mean absolute deviations are the same. It looks like our average is much higher for high school. So let's see, it says the mean number of texts for high school boys is about the same. No, because high school is larger. The mean number of texts for high school boys is less. No. The mean number of texts for high school boys is greater. Yes, because 86 is bigger than 64. And let's see, it is more likely that there are few common data values for middle school and high school boys. This is correct. And the reason why this one's true is because, yes, our mean absolute deviations are the same, however, our averages are very different. So that means that we have the same, like, we have the same spread of data, but the spread of data is shifted with one that has higher numbers and then versus one that has lower numbers. What is the median of the following box plot? So median of box plots is always going to be the line in the middle. So median here is 12. What is the range of this box plot? To find your range, you want to take your biggest number and subtract it from your smallest number. So this would be 18 minus 8, which gives me 10. My range here is 10. What is the interquartile range of the following box plot? So to find your interquartile range, we need to do 15 minus 10. You're taking that right side minus your left side of your box. So 15 minus 10 gives me 5. Right? If I follow this down, it lands at 15. Follow this down, it lands at 10. So the graph below summarizes the number of items sold by two classes for a student for a school fundraiser, and the teachers in each class compare the results side by side and determine that class 1 had more variability than class 2. We want to know which statement best describes the conclusion of the teachers. Okay, so the teachers say that the results are side by side and determine that class 1 has more variability than class 2. So class 1, if you look, the starting number is probably somewhere at 1, ending number is at 20. For class 2, it starts at 5, which means class 1 has a wider spread, or the range would also be bigger. So it is true because the range of class 1, meaning the starting and the ending point, is bigger than the starting and the ending point of class 2. Right? The box plot for class 1 is much longer. Alright, we have another box plot here, and we want to know which statement best compares the groups. Okay, and it looks like, so we're comparing the variabilities. Remember, variability is how much bigger one is than the other. So if I'm looking for a box plot that has more variability, I want it to be wider, which would be group A. So group A is going to have that more variability. And then if I look at the reasonings, let's see, group A has more variability in attendance because the maximum is greater. Well, that's not necessarily true. Group A has more variability in attendance because the IQR and range are greater. Yes, that's what we just said, right? The starting and ending point, which would be your range, is bigger than the group B. All right, scientists have this chart here, and it informs us about the sizes of leaves on maple trees. The results are shown here. Enter the difference in the difference between the medians. Okay, so median is going to be that center, the line inside your box plot. So the median for ash is 3.6, and the median for sugar maple, if I follow this down carefully, is 4.8. So all we need to do is subtract them because it's asking for the difference, which gives me 1.2. So difference would be 1.2 inches. Alright, we have a box plot here, two of them. We want to know which statement describes the difference in their median attendances in terms of IQR. Okay, so event A has a median of 15 and event B has a median of 13. So if I were to subtract them, 15 minus 13 is 2. So they are about they're 2 units apart, the medians. And the IQR, which would be the right side minus left side of your box, so this would be 17 minus 12, which is 5, and 15 minus 10, which is 5. So if I were to take 2 and divide it by 5, right, so I got that 2 by doing 15 minus 13. And then let's divide it by 5, which is my IQR. I would get 0.4, which is very close to about 0.5. So the difference between these medians would be about 0.5. Right, here we have a box plot representing Minneapolis and Annapolis for 2 weeks in January for about the temperature. And we want to know which statements best compare these two cities, and we're going to select 3 of them that apply. And yes, there are a lot of options for this question. So let's start by well, looking at the numbers on the bottom, it looks like Minneapolis is going to be much colder because it goes from 0 to 20 compared to Annapolis, which is 30 to 50. So I would say that they're not going to have any temperatures in common. Okay, so there's no temperatures in common because this goes from 0 to 20 and this is going from 30 to 50, right? No temperatures overlap in between these. So I'm going to cross out any of them that mention there could be some that are the same, which looks like it's just this one to kind of get more off the board. All right, next. So the range for Minneapolis is 20 minus 0, which is 20. So range here is going to be 20. The range for Annapolis, which is 50 minus 30, is also 20. So that means that the range for both of these cities is the same. So the range is the same, crossing off the other ones that talk about range. Then let's look at variability. So the variability, both of these have the same exact range, which means that the variability is also the same. So the variability of temperatures for the two cities are the same. So for this question, we are choosing all of they're the same options, but there's no temperatures that are in common. And that is all that I have. Thank you guys so much for watching. If you have any questions or would like a retake on this exam, please let me know. Also notice how much I used a calculator on this, just the review. So please use that Desmos calculator while you're taking your exam. All right, have a wonderful rest of your day.